In our last video, we went over a fairly intuitive explanation of how to find this area right here, the area bound by a polar curve. In this video, I just want to go over a few examples. So I have a polar graph here that I got from Desmos. This is the graph of r equals the square root of sine theta. It looks a bit like, I don't know what it looks like. It just looks like a squished circle. But that's kind of besides the point. Now we're trying to find the area of this segment right here. Now in the last video, I tried to express everything in terms of degrees to make it easier and more intuitive for you to understand. But usually we want to try and use radians as much as we can, just because it makes the math look cleaner, and as you get higher up in math, it's recommended that you use radians. With that said, it looks like we're trying to find the area of the segment between pi over 4 radians and pi over 2 radians. Now that we have the bounds, we can just simply use our formula and then see what answer we get. So let's solve for a, where a represents the area. Let's set up our integral sign. We know our bounds from pi over 4 to pi over 2 of 1/2 and r squared. So what is r squared? It's going to be square root of sine theta squared, which is just sine theta d theta. Okay, now this becomes a pretty elementary integral. We take out the 1/2 because it's a constant. Now we just have sine theta d theta, and that's also fairly simple to do. That just becomes negative cosine theta evaluated crucially at pi over 2 and pi over 4. Okay. Now from here, we can just do some pretty simple math. If you need a calculator, you should probably use it here, but I have these memorized, so it should become fairly easy. So we have first negative cosine of pi over 2. Pi over 2, cosine is just going to be 0. Then we have negative cosine of pi over 4, which in this case is probably, or not probably, it is exactly negative root 2 over 2. These signs cancel out to become pluses. And then we just get 1/2 root 2 over 2, or more simply, root 2 over 4. And there you have it. This is quite simply the area between pi over 4 and pi over 2 of the graph of r equals the square root of sine theta.